Sorry about that. Decided 15 minutes was too long, so I didn't give a really good sign off. I'm still going to do the one more video, or one more problem, so here it is. We're going to work this word problem. The more I looked at it, the more I thought that I might want to make this its own video, so that way you could look at that and play it as much as you need. Let's go ahead and pull up the screen sketch. There we go. So it says, make sure I got this on. All right, here we go, right here. Yeah. So it says, Anna dives into a pool off of a springboard high dive. Now her height in meters above water, X seconds after diving, is modeled by that equation. So if you just think about the scenario here, we got a springboard here, right? You got water here, right? That's what it looks like. And so it's going to look something like this, probably. Like something like that, right? What is the height of Anna above the water at the time of diving? So they're wanting to know what is her height there. Well, you may say, well, it's at the beginning, so 0. Well, its time is 0. So remember, time is the independent variable here. The height is the dependent variable, okay? So at time 0, well, which variable is acting like time? Well, x, because it's x seconds. So it's 0. So if we plug in 0, so this time it's not zero product property. It's literally the time is 0, so plug in 0. So we have h of x is equal to -5 times 0 plus 1 times 0 minus 3. Well, that's -5 times 1 times -3. There we go, put that there. And then so first, this is a word problem. So I like the word problem in that we can make sure that there's a positive value here. If it's a negative value, then we know that it's impossible. That means she's underwater when she jumps, and that's impossible. So we know it should be a positive value, and a negative times a negative does make a positive. So now we just figure out 5 times 1 times 3 is 15. So 15. So 15 what, though? So 15, her height is modeled by that. What is her? Okay, so it's in meters, so 15 meters is our answer. So we plug in 15. There we go. We'll do one more. There we go. You know what? Same exact scenario here. So this is awesome. So we can think back. You can go back to a minute ago or so, whatever, a couple minutes ago. You can see that image. So if you remember, we figured out what was her height at the beginning. So I'll make my colors what I did before. So we had the board, we got the water. We figured out her height from here to there is 15 meters, right? And she jumped from here to here, like that. It says how many seconds after diving will Anna hit the water? So they want to now know that number. They want to know, when does that occur? When does the height equal 0? When does height? This is zero product property is what this is. So now when h is 0, so 0 equals -5 times x plus 1 times x minus 3. Well, obviously 0 is going to be set equal to each thing. Obviously 0 does not equal -5. X plus 1 equals 0. X minus 3 equals 0. So x equals -1 and x equals 3. So now the question is, okay, it's asked how many seconds. We have 2 answers here. How do we fix the situation here? It's a word problem. Think about context. X represents seconds. So we have 2 possible answers here. X could equal -1 or 3. One of those should make sense to you. Hopefully you understand that, you know what, that one right there, it's impossible. She can't hit the water in -1 seconds. That means it happened before. What that's describing is if you follow here, it's describing this. It also hits it there, but she's already above the water. She's already on a board, and she's jumping off into it. Make sure I'm going the right way for you guys. Yeah, okay. So she's already going off into it. So here, if this is our if these are our coordinates, there's your -1, there's your 3. Obviously, it has to be 3. So 3 seconds has to be our answer here. We'll do this last one. Simon has 160 meters of fencing to build a rectangular garden. Now, the garden's area in square meters as a function of the garden's width, W, in meters, is modeled by AW, or A of W is equal to -W times W minus 80. What is the maximum area possible? Okay, so in quadratics, anytime we're asked what is a maximum or minimum, think about that. You're not dealing with X and Y intercepts hardly anymore, okay? You're dealing with the area right here. So let's pull up our sketch pad real quickly. One last one here. So now we're dealing with that area, right? They want to know, when is it at its maximum? Well, notice that negative right there, right? You know it's doing this, right? You know you got a parabola opening down. If they're looking for a maximum, right? We're looking for the vertex here. Looking for a vertex. So first we had to use zero product property to find our two x-intercepts, okay? So zero product property. So if the area was 0, that equals -W times W minus 80. Well, that's 0 equals -W, and 0 equals W minus 80. So -W, that means W is equal to 0. And over here, add 80 to each side, so 80 equals W. So if those are your two extremes, two x-intercepts, the vertex is between them, right? 80 plus 0 over 2, which is 80 over 2, which is 40. 40 is perfectly in between them, right? So if I'm looking at this graph over here, here's 0, there's 80, perfectly in between them. That was a terrible line right there, but right there is 40. So what do we do with 40? Plug it in. Find the y value. The y value determines your maximum and minimum. The negative, or the 40 is just your x value for it. So now if you plug in 40 for this, you got -40 times 40 minus 80, which is -40 times -40. That's good because a negative times a negative makes positive. We have a maximum area. It should be a positive number. We're good. 40 times 40, well, 4 times 4 is 16, and there's 2 zeros, so 1,600. So there is our answer, 1,600. So I hope that helps a little bit. Got any questions? You should be able to find me on Remind. If not, I'll throw my email address on there so that way you guys can reach me if needed. Many of you guys, though, I'm still on the Remind, so that's how I know that you guys should be finishing up with your factoring and stuff like that. Again, I will try to make some more videos. I'm going to try to make some videos on the rest of the quadratics. Let's see what we got left. Yeah, quiz 1 you got. So solving quadratics are the next videos that come up. Square roots is the easy one. Quadratic vertex form, you guys will be able to do that. So you got some things coming up. Hopefully you guys are doing well without me. I know you are. You guys are very smart. So, but that's all I've got for now. I will try to make some more videos later. See ya.